Welcome to the lesson on energy.
The lesson we will be able to understand the relationship between work and energy, identify and explain the various forms of energy, derive the expression for gravitational potential energy, derive the expression for kinetic energy, explain the law of conservation of energy, and define power. What do we need to do a work?
Yes, we need energy to do any work.
There is a direct relation between work and energy. Energy is capacity to do work. Let us understand this with an example. When a cricket ball hits a stationary wicket, the wicket is thrown away. This shows that the ball possesses energy which is transmitted to wicket. Ball does the work and loses energy, while wickets on which work is done gains energy. The object which does the work loses energy. The object on which the work is done gains energy.
How does an object with energy do work?
An object that possesses energy can do work on another object. Energy is transferred during the work. The object that receives energy may move and therefore do some work.
I understand. The work basically is transfer of energy. But what about the unit of energy?
The unit of energy is the same as that of work. Thus, the unit of energy is joule. 1 joule is the energy required to do 1 joule of work. Energy in different forms. Energy of an object due to its position is called potential energy. For example, a rock at a height possesses potential energy because of its position above the ground level. When this rock rolls down, then the moving rock possesses energy, which is called kinetic energy. Kinetic energy is the energy possessed by an object due to its motion. This water has potential energy. This potential energy converts into kinetic energy when it is allowed to flow, which in turn rotates the turbine and generates electrical energy. Electrical energy is required to run electrical appliances like refrigerator, television, computer, and much more. Sun is the biggest source of light energy. The energy that enables us to view things is called light energy. Light energy can be converted to heat energy in a solar cooker. Light energy is used by the plants for the process of photosynthesis. Plants prepare food using light and carbon dioxide, which is a form of chemical energy. Heat energy or thermal energy is the energy that gives us the sensation of heat. For example, heat from burning wood helps to cook food. During a power cut, what do we use to get light?
We use our torch.
Yes, another form of energy that we are refreshing is chemical energy. Chemical energy in the batteries is converted to light energy. Energy which is released as a result of chemical reaction is called chemical energy. Now, Tanmay, can you tell me what the relation is between these forms of energy?
From these examples, I can understand that one form of energy is converted to another form of energy.
Very correct. Energy of an object due to its position is called potential energy. Every object that's above ground level has some potential energy. This energy is called gravitational potential energy. An object increases its energy when raised through a height. This is because work is done on it against gravity while it is being raised. The gravitational potential energy of an object is the work done in raising it from the ground to a certain point against gravity. Now you tell me, which of these books have more gravitational potential energy?
The book on the shelf has more gravitational potential energy as its height is more than the height of the book kept on the table.
Let us derive an expression for the gravitational potential energy of an object at a height. Consider an object of mass m. Let it be raised through a height h from the ground. A force is required to do this. The minimum force required to raise the object is equal to the weight of the object, that is, mg. The object gains energy equal to the work done on it. So, work done is equal to the force multiplied by displacement. W will be equal to mg multiplied by height h, which is equal to mgh. Since work done on the object is equal to mgh, so energy equal to mgh units is gained by the object. This is potential energy. This potential energy is independent of the path of the object, which it follows while raising. The given figure shows that if the block is raised from A to B, taking two different paths, then in both the cases the work done is the same. Hence, potential energy of B is same in both the cases. Kinetic energy is the energy possessed by an object due to its motion. The kinetic energy of an object increases with its speed.
How does that happen, Dad?
Consider the same example of the cricket ball hitting the wickets. Object moving faster can do more work than an identical object moving relatively slow. Kinetic energy of the cricket ball with a certain velocity is equal to the work done on it to make it acquire that velocity.
Can we express kinetic energy in terms of equation?
Yes, let us do it. Consider an object of mass m. Let its initial velocity u be 0. Let a constant force F act on the object in the direction of its displacement. The work done on the object will cause a change in its velocity from u to v. Let a be the acceleration produced. Let v be the final velocity and s be the displacement caused. According to Newton's second law, force is equal to the product of mass and acceleration. Work done on the object will be equal to force multiplied by displacement. So, W will be equal to mass multiplied by acceleration multiplied by displacement. The equation of relation of initial velocity, final velocity, and uniform acceleration of a body can be written as v square minus u square equals to 2as. This gives s equal to v square minus u square divided by 2a. Putting this equation in equation of work done, we get work done equals to half times m multiplied by v square minus u square. If the object is starting from its stationary position, that is u equals to 0, then w equals to half the product of mass and v square. So, this is also the kinetic energy. That the sum of energy can be changed from one form to another. Whenever energy gets transformed, the total energy remains unchanged.
You mean that when we cook food in a microwave, the total electrical energy used is converted to heat energy?
Yes. Similarly, when a table fan is used, then the total electrical energy used is converted into mechanical energy.
Does this energy never get used up?
No. Energy can neither be created nor be destroyed, but can change its form. The total energy before and after the transformation remains the same. A simple example. Let an object of mass m be made to fall freely from a height h. At the start, the object has only potential energy and kinetic energy is 0. Kinetic energy is 0 because its velocity is 0. The total energy of the object is mgh. During the fall, its potential energy will decrease and kinetic energy will increase. After a fall of x meters, potential energy becomes mg multiplied by h minus x, and kinetic energy becomes half the product of mass and velocity square. When the object is about to reach the ground, h equals 0 and v will be the highest. Therefore, the kinetic energy would be the largest and potential energy would become 0. However, the sum of potential energy and kinetic energy at all points would be the same. That is, potential energy plus kinetic energy is equal to constant. The sum of kinetic energy and potential energy of an object is its total mechanical energy.
At the same rate?
No, it depends upon power.
Power? What is that?
Power measures the speed of work done. That is, how fast or slow work is done. The stronger man can pull the log faster than the weaker man. Hence, we say that the stronger man has more power than the weaker man. Power is defined as the rate of doing work or the rate of transfer of energy. If W work is done in T time, then power is as given by work upon time. The unit of power is watt. 1 watt is the power of an agent, which does work at the rate of 1 joule per second.
Dad, is this power always the same in an object or a person?
No, the rate of doing work varies at different intervals of time. In that case, we obtain average power by dividing the total energy consumed by the total time taken.
Which we bought is rated 1500 watts. If we use it for 10 hours, we can get the energy it uses in 10 hours. But then this quantity will be too large to express.
Yes, the unit of energy joule is too small. Hence, to express large quantities of energy, we use a bigger unit of energy called kilowatt hour.